All right, let's take a look at lesson 323, which is titled Multiplication as Repeated Subtraction. In the past, we've made a connection between repeated addition and multiplication, but now that we're working with integers, we're going to start exploring how that works. In one of our previous times together, we talked about how when we have a subtraction of integers problem, rewriting it as an addition problem makes it much easier to solve once you get into the whole process and the practice of the thinking that goes behind it. So if I was going to rewrite this as an addition problem, I would write this as -1. The first number stays the same. I would change this to add, and then I would change the second number to its opposite. And the opposite of -6.5 is just 6.5. Now, it's much easier for me to think about this problem because I know that if I have 6.5 and I have -1, if I combine them, I know that I'm going to end up with 5.5 or 5 and 5/10. This problem here, if I'm thinking about 2 and 2/10 subtract -2 and 2/10, I have a hard time thinking about that until I rewrite it. We keep the same things about the first number. We change the operation sign to add, and we change this to the opposite, so that would be 2.2, or 2 and 2/10. Now, if I go ahead and add those, I get 4 and 4/10. This one here, it is kind of complicated to think about having 12.5 and taking 22.5 away, but it would be more complicated if one of the numbers was negative in addition to that. So I could just leave this, or I could go ahead and rewrite it 12.5 plus the opposite of 22.5, which should be -22.5. Either way, I'm going to end up with -10 because in this situation, I have 10 more negatives than I do positives. And in this situation, if I was thinking about on a number line, if I was at 12.5 and I was subtracting 22.5, I would go back towards 0 to 12.5, and then I'd go back even farther. So this is kind of a nice problem to think about in the situation that we're working through today. This problem here, if I'm going to rewrite it, this would be -100. So we keep the first number the same. We change the operation sign to add, and then we add the opposite of -98, which would be 98. And this is pretty easy for us to do in our head because these numbers are close together, and I know that there's 2 that is the difference between them, and there's more negatives, so the answer is going to be negative. This problem here, I have four numbers that I'm going to be working with. And if I go ahead and I change this up, I could rewrite it as -10 plus the opposite of -2 plus the opposite of -2 plus the opposite of -2. So this would be -10 plus 6, and that equals -4, because again, there's more negative than there are positive there. So if we take a look at this problem here, and I'll highlight it, this problem here, I have a repeated number. And it's the same problem that I'm working on for my second exercise for today. And if I was looking for a shorter way to write this, I could write -10 subtract 3 times -2. So these two are talking about the same problem. This one here might be a little bit simpler to solve. And then we have a follow-up question. What if it was just this and we had taken away the -10? So if that were the case, I can simplify this. This would become -3 times -2. And something that is going to be important for us to start getting our brain wrapped around is if the signs are the same, answer is positive. So if I have a positive times a positive, my answer is a positive. If I have a negative times a negative, my answer is positive. You might be wondering, what if the signs were different? The answer is negative. So that would be if I have an even number of factors, or if I'm doing a division problem, even number of division, excuse me, we wouldn't be doing division problems with more than one number, but if I have an even number of factors, like if I have a positive times a negative, that's going to be a negative. If I have a negative times a positive, that's going to give me a negative answer. Something to think about today.